takes place in between primary refrigerant and secondary refrigerant. Later, heat exchange takes place in between, okay, secondary refrigerant and air. This type of refrigeration system is called as indirect refrigeration system. Under indirect refrigeration system, we have three different categories: all air system, all water system, and air water system. All air system, all water system, and air water system. Now, today's session, we are going to discuss all air system. Okay, all air system. Under all air system, so all air system is having a machine called AHU. AHU is air handling unit. The air handling unit. The major components are filter, cooling coil, and a blower. I'm sorry. Okay. Now, let's assume a room requires 600 CFM of air. A room requires 600 CFM of air. So basically, AHUs are very big in shape. So like, if you are able to see, if you go to a mall or a movie theater, how much big the diesel generators are, that much big this AHUs are. So these AHUs are placed on the rooftop or in the cellars. We place AHUs on the rooftop or in the cellars. So आजकल the architects are giving a separate space called as AHU rooms. Okay, so they are giving a separate room which is called as AHU rooms. Okay, now these AHU rooms we need to utilize to place the AHU. Now, so as this is placed outside, now our condition space, okay, our condition space requires okay 600 CFM. Okay, 600 CFM. So we need to take 600 CFM from outside. So to control this 600 CFM, it is having a device. What is the device to control the air? To control the air, we have a device called VCD, volume control damper. This air will reach to the filter. Sorry, whatever the impurities. So whatever the impurities are present in this air, whatever the impurities are present will be filtered near the filter. Now this 600 CFM of air will move to the cooling coil. In the cooling coil, okay, into the cooling coil, we are going to supply 5 degrees centigrade. Just I am taking some temperature, this also to be calculated. 5 degrees centigrade of chilled water solution. Chilled water solution. 5 degrees centigrade of chilled water solution. So as it is 5 degrees centigrade of chilled water solution, so the coil is called chilled coil. Now when hot air comes in contact, with this chilled coil, so this temperature is also called as a dew point temperature. Okay, this temperature is also called as dew point temperature. So now this, okay, now the hot air will come in contact with this coil, and there will be cooling and dehumidification takes place. What happens? Cooling and dehumidification, and this air will become comfort air. Okay, comfort air. So now this comfort air needs to reach to the condition space. As earlier I said, the AHU will be somewhere outside. Okay, the AHU will be somewhere outside. So this is the comfort air. As this is the comfort air, from here this air need to reach the condition space. So you need a passage. Okay, that passage is called as duct. That passage is called as duct. We use the duct to take the air from AHU to the condition space. But okay, but from here the air need to reach to the space, so that you need some pressure, right? So to create that pressure, we use the blower. So blower is used to reach the air from this place to this place. So how duct is made? What is the material for the duct? Duct material may be GI, galvanized iron. Okay. Now, what I mean to say. Okay. How duct is made? Duct is made with GI sheets or aluminium sheets. Ducts are made with GI sheets or aluminium sheets. Sometimes it is made with what we can say stainless steel, galvanized steel, depending on the application. Okay. So now as this is exposed to outside ambient temperatures, so we need to protect the comfort air. To protect the comfort air, so the duct should be insulated. So we insulate the duct. This duct is called as supply air duct. And this duct should be insulated. Now the 600 cfm of air we have taken from outside. Okay, this air we have supplied to the conditioned space. But so if I directly supply the air to the conditioned space, it will only cool this much space only. So what you need to do? Sorry, you need to distribute the air through a air shower, which is called as terminal. You need to distribute the air by using a terminal. Like this, we'll be having a terminal and we'll be distributing the air. Now, so this is supply air terminal. We call it as a supply air terminal. Now, I supplied 600 cfm. So as per the principle, so when you supply 600 cfm to the air, that means you need to remove 600 cfm, which is called as we need to maintain. Okay, we need to maintain 600 cfm here. So once you supply 600 cfm, you need to remove 600 cfm from here. So this is called return air terminal. Okay, now so the basic principle of a design engineer. Okay, the basic principle of a design engineer is always we need to optimize the cost of the project. Okay, why we design a system? To optimize the cost of the project. So here the losses of any project, the cost of the any project has been classified into two losses. First one is one time loss and second one is lifetime loss. The first one is one time loss and second one is lifetime loss. Okay, the one time loss. Okay, the one time loss means, the one time loss indicates the initial cost of the project. The initial cost of the project is one time loss, and the lifetime loss is running cost of the project. Always the lifetime loss is greater than the one time loss. So you need to be more specific. You need to be more specific while working on the lifetime loss. You need to be more specific while working on the lifetime loss of the project. So here, once I supply 24 degrees centigrade, so that means just assume this room is now 24 degrees centigrade. The retinite temperature may be around 30 degrees centigrade. So here outside it is 40 degrees centigrade. So now to cool 30 degrees centigrade to 24 degrees centigrade will cost more, or 40 degrees centigrade to 24 degrees centigrade? Which cost more here? Which
40 to 24. 40 to 24 will cost more.
30 to 24 will cost more or cost less?
Cost less.
Yes. So when it costs less, so we can reuse that air, right? Already 30 degrees centigrade is filtered. Okay. So we can reuse that air. So as we can reuse that air. That indicates you are going to reduce the running cost of the project. Sorry. When I am going to reuse this air, I don't want to supply 5 degrees centigrade to cool 30 degrees centigrade to 24 degrees centigrade. I can increase this temperature. If I increase supply water temperature, that indicates the running cost, the machine running cost is going to be decreased. When machine running cost is going to be decreased, entire project running cost is going to be decreased. So to reduce the running cost of the project, we are going to reuse this air. So that is the reason this is called, as a return air duct. Now so a return air duct also should be insulated. If there is an increase of 2 degrees or 3 degrees centigrade, again that is going to increase the running cost of the project. If 2 to 3 degrees centigrade if increases, that again increases the running cost of the project. So even return air duct should be insulated.
One doubt, can I ask now?
Yes.
Yeah, insulation should be external or internal also?
So most of the times we go with external insulation. For rare applications like clean rooms, we go with internal insulation.
But both are not required, right? External and internal.
If the project is not allowing to take external insulation, then we'll go with internal insulation.
Yeah, but both are required. I mean, like external and internal, is it required or any one is required?
Sir, I'm not getting your point exactly.
I mean, external, if I'm suppose external and internal is both have to be done, or either external or internal, anything is fine.
Anything is fine. Only one insulation we do, either external or internal.
Okay, thank you. And is here you have given 600 CFM.
Yeah.
Yeah, is that a fixed value or only for the example you have taken?
That is, I have taken, but we need to calculate how much CFM is required to cool that room.
Okay, so
that calculations will be working in the next coming classes.
No, I got it. Okay, thank you.
Yeah.
Thank you.
And second thing, you have asked good question. The insulation materials are like a styrofoam insulation will be there. Okay, sometimes glass wool insulation will be there. Glass wool. Sometimes we go with glass wool, styrofoam, nitrile rubber. Okay, nitrile rubber insulation will be there. Okay, some applications, suppose if in the hospitals we can't go with glass wool or fiberglass, we say fiberglass insulation cannot be taken. So at that time, particularly in the hospital application, we choose nitrile rubber. Okay, sometimes in the application like pharmaceutical labs, you can't insulate outside of the duct clean room. Why? Because that insulation may, some fungus may form. So that is the reason we go with internal insulations there. So depending, okay, depending on the type of the project, okay, depending on the type of the project, we go. Sometimes if you come to the external insulation, sometimes some projects we go with the external insulation, but we do the aluminum cladding again. We go with aluminum cladding where the insulation material is not directly exposed to the interior space. So different methodologies we follow depending on the type of the project. So once, if you want to create a project, you will get a project report. First, we won't directly start the project. We'll get a project report stating that we need this type of this much temperature is required. Okay, this much RH is required. Mostly, if when you are working for industrial application, I am talking. This is the thickness of insulation you need to take. This type of insulation material should not be taken. So every industrial application, they have their own specific considerations. Okay, so before going to start the project, you'll get the list of the considerations. By using that list of the considerations, we'll start the designing of the project. Okay, now, so this air is going here and coming back and cooling down here and coming supplying to the room. There is a big issue with the system right now. There is a big issue with this system right now. The issue is, okay, the issue is when the same quantity of air is recirculated for a long time. So the oxygen level of the oxygen level of this air is going to decrease. When the oxygen level is going to be decreased, when the oxygen level is going to be decreased, it starts again with the suffocation. It starts again with the suffocation. So what we are going to do is, again, what we are going to do is, we are going to exchange the air gradually. We are going to exchange the air gradually. So now this is called as exhaust air duct. What I am going to do is, because this is one VCD and this is one VCD. Now what we are going to do is, in the first cycle, when first cycle happens, I'll take 590 CFM. 590 CFM. I'll exhaust 10 CFM out. So when I exhaust 10 CFM out, this 590 CFM, I'll add 10 CFM from outside. CFM from outside. Now, so in the first cycle happens. The first minute, the first cycle takes place. I'll add 10 CFM of fresh air from outside. In the second minute, again I'll add 10 CFM. Already 10 CFM of outside air is added. So it will be 20 CFM of fresh air now. Third minute, 30 CFM of fresh air is added. 10 minutes, 100 CFM हो जाएगा. 60 minutes, 600 CFM. So here, listen carefully. 600 CFM is being replaced with 600 CFM. How many times? Only one time. 600 CFM is being replaced with 600 CFM only one time. To replace 600 CFM with the 600 CFM one time, how much time it has taken? It has taken 60 minutes. Okay, which we call it as 1 air change per hour. 600 CFM is replaced with 600 CFM, 1 air change. In how much time? In 1 hour, which is called as 1 air change per hour. So this is called as 1 air change per hour. Okay, so this is again ASHRAE has given some standards. The generic standards I am giving here for residential application. We have 1 air change per hour is required. So for commercials like malls, airports, restaurants, we go with 2 air changes per hour. So to achieve 2 air changes per hour, every minute we need to remove 20 CFM. To achieve 2 air changes per hour, every minute we need to remove 20 CFM.
I think 5 CFM, right?
How much? 5 CFM?
2 air changes per hour. Okay. Got it. Yeah.
Next, for bars, pubs, malls, for bars and pubs, the application, it needs to be 3 air changes per hour. Okay. Next, for industrial application, we need to go with 6 to 10 air changes per hour. Next, for clean rooms, we say for clean rooms, we go with 20 to, depending on the type of application, 20 to 240 air changes per hour. Okay, so these are the different air change rates depending on the type of the application.
For hospitals?
Yes.
For hospitals.
So hospitals, it comes under different applications as hospitals. Some if you come to the ICUs, okay, hospital is a completely a different application where you need to follow different designing aspects. Suppose if you have a suppose what we can say, if you have a hospital operation theater, okay, in the operation theater you need to install a separate AHU. So in the operation theater you will go with 60 air changes per hour. Okay, clean room again. So coming to the ICUs 4 to 8 air changes per hour. Okay, critical ICUs again 10 air changes per hour. Coming to the inpatient wards, 2 to 3 air changes per hour. Okay, general application, commercial application, you can go on. But when you come to the ICUs and operation theaters, depending, you need to follow the national hospitality standards again. So in the operation theaters also, we have two types of operation theater. One is general operation theater, one is super specialty operation theater. Again, coming to the super specialty operation theater, it is a clean room. General operation theater is not a clean room. So in the general operation theater, you can go with 4 to 8 changes per hour. But if you come to the super specialty operation theater, again, you need to go with 68 changes per hour. Hope it is clear.
Yes, yes. National Hospital Index. Huh?
Yeah, National Hospitality Standards.
Okay.
Okay, clear? Next. So hope it is clear. This part is clear to everyone, right?
Yes, yes.
Yes.
Now, I'll be telling you from where we are going to supply this chilled water. Okay.
Till now, can we take the notes? 1 minute.
I'll give time. No worries. You wait. I'll give time to complete. Why? Because drawing is very big. Sir, please allow me 1 minute, please.
Please take your time, sir.
No. Sorry. Okay. So now we start from compressor. So compressor compresses the refrigerant to very high temperature, right? Here we had a mistake. Okay, compressor compresses the refrigerant to very high temperature. Now it enters into the condenser. Okay, it enters into 1 minute, sir. Ma, పెద్దమ్మ పిలుస్తాను చూడు. Okay. Compressor compresses the refrigerant to very high temperature and very high pressure. Now, as it compresses to very high temperature, very high pressure, from cooling tower, this is called as cooling tower. From cooling tower, we supply cold water to decrease the temperature. We supply cold water to decrease the temperature of the refrigerant. Previously we used to use air, right? Now we are using cold water. How we supply? By using a pump. We call as condenser pumps. These pumps. Okay. Now, so this air, this water enters in. It's a shell and coil or shell and tube type of compressor, condenser. Very high temperature will become high temperature refrigerant. So cold water will become hot water, right? This hot water is pumped back to the cooling tower. And we throw the air in the form of tiny water droplets. So by using an axial fan here, we remove the heat. We remove the heat from the cooling tower. So whenever the process is happening, there may be a chance some water may get evaporated. There is a chance that some water may get evaporated. As the water gets evaporated, so we need to balance that water. It is connected to makeup water tank. This makeup water tank, here we have a floating wall. Whenever water level decreases, whenever the water level decreases, this makeup water tank will supply the water to the cooling tower. Now this hot refrigerant will move to the expansion valve. And will become chilled refrigerant. Now this chilled refrigerant will enter into the evaporator. The chilled refrigerant will enter into the evaporator. Now this chilled water piping, this is called as chilled water piping. So this chilled water piping is charged with water. Previous itself, it is charged with water. This is having water inside. So this is chilled water piping. So now we supply cold water into the evaporator. So this cold water heat transfer takes place between cold water and chilled refrigerant. This water will become chilled water of 5 degrees centigrade. Chilled water. This chilled refrigerant will become cold refrigerant. This cold refrigerant again moves back. To the compressor, compresses to very high temperature refrigerant. Now this chilled water is supplied by using a chilled water pump. This is called chilled water pump. Using a chilled water pump, we supply this chilled water to the cooling tower. So as Return temperature may be around 20 degrees centigrade. Supply temperature is 5 degrees centigrade. As these are dealing with lower temperature side, the the chilled water piping, should be insulated again. The chilled water piping should be insulated. So we go with puff insulation. Okay, we go with puff insulation. Puff is polyurethane foam. Puff is polyurethane foam insulation. We go. Polyurethane foam puff insulation. Mostly 99% we go with puff insulation only. Polyurethane foam. Why it is best insulation with respect to cost is low. Okay. Now this equipment, the equipment which I am talking is called as chiller equipment. Okay, and this piping is called as condenser piping. Condenser piping is not required any type of insulation. Condenser piping is not required with any type of insulation. Okay, hope you are clear with this, sir.
Yes, is this PPR or any UPVC can use?
Yes.
Is this pipes PPR or UPVC or CPVC?
Pipes are not CPVC, sir. Pipes are made with GS, galvanized steel भी हो सकता है, mild steel भी हो सकता है.
Okay, so iron pipes.
Why? Because they are working with high pressures.
Okay.
Okay.
Yeah.
So I'll show you one video which explains all this in an animated way so that you can understand it very easily. Okay.
Yes. Yeah.
Hello.
Yeah.
Actually, sir, we are giving the chill water from evaporator to the coil of AHU. So that particular water need to refill, or that's a particular solution to.
1 minute. Repeat your question now.
As we see, if the level of water is get down, then we are giving makeup water tank to the cooling tower. The same principle is followed here, like if the comfort air is throwing through blower from that coil, and the chill water is coming from the evaporator coil of the chiller, and then how the air water level is maintained in that particular line.
Yeah.
Or is there any some particular solution to exchange the heat?
Yeah. Okay. If you see this cycle, are you able to see this cycle? Okay, this cycle is completely closed. Nowhere it is exposing to atmosphere. There is no chance of evaporation.
Yes.
Okay. Still, there may be. Okay, if it evaporates, we have a air vents. Air vents will put and we will remove that air. To this level, to this, what we do is we connect with the expansion tank here. An expansion tank will come. So this expansion tank, why? Because when you cool the air, when the air is working on different temperatures, it contracts and expands. So that may create some problem in the piping. Okay, so there may be a leak, there may be a breakage in between here the pump. So what we do is we connect with the expansion water tank level to this AC. Okay, there this water level increase, we add the makeup water from the expansion. Water
Okay.
solution
We are using water there only, or using any other solution?
Yes, that is
Because
what I'm
somewhere
talking.
I saw
We are
that they are
using a
using brine solution there.
using a glycol, methanol, different types of solutions depending on this temperature. We calculate this. If it is less than 4 degrees centigrade, if this is less than 4 degrees centigrade, we use a brine solution. Why we use brine solution is at 0 to 4 degrees centigrade, basically 0, but still there is a chance 0 to 4 degrees, 0 degrees centigrade mostly you take. The water, what happens? Freezes, right? The water freezes. Yeah. So
Because it has a freezing point lesser than water.
If water freezes here, the cycle will not happen. It will block. So that is the reason. If I go with the brine solution, the brine solution is minus 10 degrees centigrade to 15 degrees centigrade. The freezing point. So we use the brine solution instead of using a water. So that is the reason I have written here. It is very clearly written here. Chilled water solution.
Okay. So is there any particular standard solution we are using, or using any standard solution that particular we are using commonly?
Mostly. Why? Because just when you come to the industrial application, when you are designing something like cold storages, okay, then you need to follow a different principle, not different principle. We'll have that standard again. That standard from the standard book. You can see which solution should be used for that particular temperature. There is very clearly mentioned. Yeah.
Okay. Okay, got that.
టికెట్లు చేస్తుంది సింపుల్ గా ఈ సూపర్ వచ్చేసింది ఏంజెల్ 1 సూపర్ యాప్. ఇది భారతదేశం యొక్క ఇన్వెస్టింగ్ ని చేస్తుంది. Super.
Investments in securities market are subject to market risks. Read all the related documents carefully before investing.
Creating a website can be complex. Choose Hostinger, a simple place to host your WordPress site. You'll love the quick access intuitive control panel and its sleek design.
Large cooling capacity. Usually for commercial purposes. Chiller system consists of 3 main cycle, which are refrigerant cycle, chilled water cycle, and condenser water cycle. The components that are involved in refrigerant cycle are compressor, condenser, filter dryer, expansion valve and evaporator. For chilled water cycle, the component which involved are air handling unit and water pump. In condenser water cycle, the component that are needed for the process are cooling tower and water pump. Refrigerant cycle. Refrigerant cycle consists of 4 basic components, which are compressor, condenser, expansion device and evaporator. An additional component called filter dryer also include in the system. Compressor. Compressor works to increase the pressure of the refrigerant. In addition, it also serves to increase the temperature of the refrigerant higher than the temperature of condenser water so that the heat transfer can occur in the condenser. The refrigerant enters the compressor with low pressure gas and out with a high pressure gas condition. Type of compressor used was scroll hermetic type. Scroll compressor works based on gas at low pressure and temperature enter the suction line and go into the compressor. The low pressure and temperature gas is pressurized by the scroll compressor to high pressure and temperature gas. The high pressure and temperature gas is then passed through the discharge line and then go into the condenser. Condenser. The refrigerant in high pressure gas will be enter the condenser at a temperature higher than the temperature of condenser water. In condenser, The heat will be eliminated to the condenser water from the cooling tower through the process of convection and conduction. After the heat is removed, the refrigerant in high-pressure gas is condensed into a high-pressure liquid when out of the condenser. Condenser most commonly used is shell and tube type. Water is flowing through the tube while refrigerant liquid flooded in the shell. Filter dryer. Before the refrigerant flow to the next main component, it will be passes through an additional component called dryer. Dryer acts as a dirt filter and absorb if there is moisture in the refrigerant. This ensures that refrigerant is clean and dry before entering the expansion valve. Expansion valve. Expansion valve serves to reduce the pressure and control the flow of refrigerant going into the evaporator. When the pressure of refrigerant has declined drastically, the temperature will drop dramatically, which is lower than chilled water temperature. In a centralized system, expansion device DXV thermal expansion valve type is used. It works according to the temperature of the refrigerant which comes out from the evaporator. Sensing bulb placed on outflow of the evaporator works to detect temperature of the refrigerant and sends a signal to TXV. Needle valve in the TXV will control the flow of refrigerant based on the transmitted signal. Evaporator. The refrigerant in low-pressure liquid form coming out from the expansion valve will flow into the evaporator at low temperature. In evaporator, the heat from the chilled water which comes out from the air handling unit will be absorbed by the refrigerant due to the temperature difference produced. When the liquid refrigerant with low temperature and pressure absorb heat from the chilled water, the refrigerant will evaporate to low-pressure gas. The evaporator most commonly is used shell and tube type, where the refrigerant flow in the tube and the water flooded the shell. The evaporator is insulated with an insulation to reduce heat transfer. The refrigerant in low-pressure gas will return to the compressor and continue to the next cycle. Chilled water cycle. Chilled water cycle consists of two basic components which are air handling unit and water pump. Air handling unit. Air handling unit is a place where cold air is produced before it can be distributed. It consists of several key components such as cooling coil, fan motor, belting, filters and the casing. Chilled water produced in the evaporator will be flow into the air handling unit through a pipeline which is marked with dark blue color. This chilled water is known as chilled water supply. In air handling units, chilled water will then pass through the cooling coil. In the cooling coil, the hot air will go through the cooling coil and switch to cold air due to the heat transferred to chilled water. Cooling coil are commonly used in this system are tube and fin. After absorbing heat from the hot air, the chilled water will be known as chilled water return. Normally chilled water return pipe will be colored with light blue. Chilled water return will return back to the chiller to transfer the heat absorbed to the refrigerant in the evaporator. Water pump. This cycle will continue as long as the pump is functioning well. The pump used in the system is centrifugal type. The centrifugal pump works based on centrifugal force produced by the rotating impeller in the pump casing. For airflow system, it is operated using an auxiliary fan which to create the air cycle from the room and mix it with fresh air from the outside to the air handling unit and return back to the room. Type of fan used was centrifugal fan and powered by a motor and connected through a belting. The air flowing through a channel is called ducting. There are two types of air duct which are supply air duct and return air duct. These air ducts are coated with insulating material consisting of fiberglass wrapping with aluminium foil. It reduces heat transfer from the environment to the air duct. Air return to the air handling unit will pass through the filter before passing through a cooling coil and return back to the room. This to ensure that the air return into the room in a clean condition. Condenser water cycle. Condenser water cycle consists of two basic components, which are cooling tower and water pump. Cooling tower. Cooling tower serves to cool down the temperature of condenser water that will be used to absorb heat in the refrigerant at the condenser. It consists of several components, which are motor, sprinkler blade, water fin, water reservoir, buoys, and make-up water tank. From the condenser in chiller, condenser water flow to the cooling tower with the help of a centrifugal pumps. This chilled water is called condenser water return. This condenser water will pass through the rotating sprinkler blades on cooling towers. This rotating rotor blades using pressure generated by the condenser water itself. Water will gush down through the fins to reduce the speed of water going down. This can delay the time and the heat can be absorbed more effectively by the surrounding air that passing through the fins. Air through the fins is forced by a rotating fan on the sprinkler blade rotated by the motor. This fan rotates with its gusts upward. This will cause the air to move from the bottom to the top of the cooling tower where it is opposite to the flow of the condenser water. Condenser water which have eliminated their heat by the surrounding air will accumulate in the basin under the cooling tower. Condenser water that flowing out from cooling tower to the chiller is called condenser water supply. This condenser water will flow back to the chiller to continue heat absorbing work from the refrigerant. The buoy system at the water basin is connected to the make-up water tank. It works for adding water when the water level in the basin decreases at certain level due to evaporation. This condenser water cycle will continuously flow as long as the centrifugal pump is in good working condition. This explanation hopefully will enhance the student comprehension regarding the system. The centralized air conditioning is the commonly used system and it's very important to the student to well know the system.
Hope you got some idea regarding that, right? So where you are getting confused, let me know.
Yes, but confused.
Okay.
Yeah, I'll go through the recording session again, and tomorrow before the class, I'll or after the class we'll catch up. Yeah.
Yeah, I'm sharing.
Can you please share the screen? Can you please zoom out? Vinod ji. Hello, Vinod. Vinod. Vinod, can you please zoom out the drawing? Yeah, thank you.
Is it done?
Hello. Hello.
Yeah, I'm
Yes.
moving.
It's and can you move the air change per hour? Yes. So detailed
I'm
class.
not getting your
means
question.
heat load detailed class. It will come, right? No. Means the E20 sheet, heat load
Yes, it will
calculation.
come.
So
Yes,
for
yes.
this air change per hour and all, it will come, right? Further class. Yeah.
Sir, can you move bit
Left
to
unit.
the left?
Here.
Yeah, enough. No. Yeah, it's enough.
Is it done? Okay.
Yes.
So we'll take break here. So you revise it. The next concept, whatever the next concept is going to come, all water system and air water system will come from this concept. So before going to leave, so let me explain you one more concept here. So this is completely for summer. In winter, what we need to do in winter? Heating and humidification. How will you achieve that?
Heating,
Any
humidification.
idea?
Change this one condenser.
Very good. Heating coil.
No, heating coil.
Heating coil. To
You
the
have to
heating
make
coil,
heating-
what will we supply?
It will be heating coil will be there, no?
Is it with electric heating coil?
Just electric supply, na?
So to cool an airport. Okay.
Yeah, electric
To cool
heating
airport, like you are from Muhammad?
coil.
You are from Karnataka?
I'm from Tamil Nadu.
Tamil Nadu. So just take an example of
No,
Delhi
I'm
airport.
from Tamil Nadu.
So today temperature is 8 degrees centigrade. I need to heat the Delhi airport. I need to supply hot air. How much kilowatt of coil is required? Do you think what is the kilowatt for iron press in our home? It's up to 2 kilowatt, right? Now just imagine to cool an airport like Delhi,
Seems.
how much kilowatt of how much kilowatt?
The same thing. The based on the for example 6,000 CFM, in a sense, same 6,000
I'm
CFM.
not. I'm
We
general
have to
asking. My question
heat
is
load
in a general
calculation. In
way.
that heat load
To
calculation,
heat an airport
we will.
like Delhi,
Mm, mm,
you
mm.
require huge quantity of heating, right? So it is not possible with electric coil. So instead
Right,
of
right.
electric coil, we supply hot water.
Okay. Then hot.
Okay, we
Oh,
use
okay.
hot water generators.
Yeah, yeah. Okay.
We have a device called hot water generators. So this hot water generator is connected to this. So now this system, is closed. We have a hot water generator. So to heat, for heating purpose, for humidification, we have a separate device called as humidifier. Okay, we have a humidifier. This humidifier will supply steam. This humidifier will supply steam to the duct. From here we get hot air, and here the steam is added. That means water vapor molecules is added, so that we achieve heating and humidification. So, are you able to see the image here? This is called as a duct humidifier. Okay, this image is called as duct humidifier. So to the duct humidifier, we supply water. Okay, we'll supply water. See here. So we supply water. So whenever we are supplying water to this duct humidifier, it converts water into water vapor. It is getting converted water into water vapor. That water vapor is directly added to the duct. Okay. Hope you are clear, right? So you can add this to your drawing. One more.
Yes.
Add this to your drawing. This too. Are done? Is it done? Okay. We'll meet tomorrow. with all water and
Yes.
air water system, as well as we'll start duct designing tomorrow. Okay. Okay. Thank you, everyone. Thank you.
Sure. Thank you. Thank you.
Thank you, sir.